Hello everyone, this is Earth Science teacher Tim Martin, and in this video I want to review some basic motions of the moon and how calendars have been developed. Start out with some basic definitions. The moon is a satellite. Well, what is a satellite? A satellite is an object that's in orbit of another body. The smaller one of the two is considered the satellite. A moon? Well, that's a natural satellite, not one made by humans. The moon, on the other hand, is the natural satellite of planet Earth. Well, speaking of satellites, it's worth noting that the moon is a satellite. It's in orbit of Earth. The moon's orbit of Earth is why we see different shapes of the moon at different times throughout the month. If you're not familiar with the phases of the moon, I'd encourage you to go back and watch the video in this series about the moon phases, so you have an understanding of why the moon changes in shape throughout the month. This animation, produced by the University of Wisconsin, is what's called a lunation. Here we can see the different phases of the moon throughout the month. But if we examine this closely, we see several more things beyond just the changing shape of the moon. You may notice that the moon appears to be getting larger and smaller. You also may notice that it has a little bit of a wobble. And also, if you're carefully observing, you'll see that only one side of the moon is ever pointed our direction. In this animation, you can see a red dot on the side of the moon. As the moon orbits the Earth, the same side of the moon always is facing our planet. There's only been a few people to see the backside of the moon. Those were the Apollo astronauts that actually orbited the moon. As far as the moon changing in size, that's due to changes in the moon's orbit. Since the orbit is not perfectly circular, sometimes the moon is a little bit closer, sometimes it's a little further away. There's about a 10% variation from when the moon is close at perigee and when it's further away at apogee. These two images of the moon were taken with the same camera and the same telescope. The image on the left was taken when the moon was further away. The image on the right, taken at perigee when the moon was close, is sometimes referred to as a supermoon. That's when the moon is closest to the Earth in its orbit. This is very difficult to observe just with one's eyes, but with a camera and telescope, a slight change in size is perceptible. A bit more about the moon's orbit. It takes 27.3 days for the moon to orbit the Earth, but it's 29.5 days from new moon to the next new moon. Let's take a look at this with a little more detail and an animation. In this animation, we can see that we're starting out with the full moon position. The moon is on the opposite side of the Earth from the sun. As we put this into motion, we can see the Earth rotating and the moon making its slow journey around the Earth, coming past last quarter and now almost to new moon. As the moon continues on its journey, making its way around the Earth, we'll notice that when the moon gets to the right-hand side again, it should be full moon, but it's not quite in alignment. We need another 2 days. You may notice that the Earth itself is moving. As the Earth orbits the sun, another 2 days is required for the moon to catch up in its orbit. So that explains why the lunar cycle at 29.5 days is slightly more than 2 days longer than the lunar orbit. The lunar cycle is longer because Earth is moving as it goes around the sun. These motions have been used to mark time and create astronomical calendars. We'll start off with the day. Well, one rotation of the Earth is 23 hours and 56 minutes. However, due to Earth's motion around the sun, sunrise to the next sunrise is 24 hours. A month, or should I say a month, is 27.3 days. Well, that's how long it takes for the moon to orbit the Earth, but the lunar cycle is 29.5 days. And then we come to the year. Well, or the year-ish. One orbit of the Earth around the sun takes approximately 365.25 days. There are approximately 12 orbits of the moon around the Earth during this time period. You'll notice that the day, month, and year are not equal divisions, so making a calendar presents a bit of a challenge. Many different cultures around the world have attempted different methods to take these motions and use them to mark time. Let's look at a few of the prominent calendars. The Jewish or the Hebrew calendar is a very old calendar. The year 2020 will be the year 5781 in the Hebrew calendar. This is a 12-month calendar, although every 2 or 3 years it's a 13-month calendar. That totals for 7 times in 19 years, there's a 13-month year. This is a very accurate calendar, although it's off by approximately 1 day every 231 solar years. In the Muslim calendar, the year 2020 will be the year 1441. This is a strictly lunar calendar. It just follows the phases of the moon. That means that the religious holidays fall in different seasons on different years. The Mayan calendar is one of the longest calendars that I'm aware of. January 1st, 2020 will be the 7th tune of the 0 Katun and the 13th Baktun. Baktuns are very long count calendars that account for over 5,000 years. These complex cycles involve the Earth's motion around the Sun, the orbit of the planet Venus, various aspects of the Earth's seasons and human pregnancy, and many more cycles that figure into this very complicated calendar. European cultures also developed calendars. Did you ever wonder why October was no longer the 8th month, or December wasn't the 10th month? For Europeans, this calendar changed the 10-month system. The Julian calendar, established over 2,060 years ago, was a 12-month calendar. Each month consisted of 30 or 31 days, and February having 29 days. This calendar introduced a leap year. They realized the sun's motion across the sky could not be divided into equal days. With a calculation of the year to be 365.25 days, they added an extra day every 4th year. Then the Gregorian calendar. The Catholic Church, under the auspices of Pope Gregory, realized that many of the religious holidays were falling out of sync with the seasons. This is due to the Earth's precession, or the wobble on the Earth's axis. Because of this, there was an effort to adjust the calendar so that these religious holidays would continue to fall in the same season. They calculated that the year should be 365.24 days long rather than 365.25 days. Added a leap year every 4 years, except for the years ending in 00, and except for the ones of those divisible by 400. Although it was developed in 1582, many Protestant countries were much slower in adopting this calendar. It wasn't until the middle 1700s that the United States developed this calendar system. So many dates in history were marked in either the Julian calendar or the Gregorian calendar, and there may be conflict as to when certain people were born or when certain events happened. This is the calendar that most countries around the world use today. Overall, this calendar is only off by 26 seconds. Pretty amazing to consider when this calendar was set up back in 1582. I also find it fascinating to contemplate that these calendars have been developed by carefully watching the motions of the moon and the earth and the stars and the sun. Thanks for watching, and I hope you join me on another video that describes more about the moon.